Hello, welcome to our training session today. My name is Bart, and today the topic is exploring trend analytics for spatial-temporal insights. This session will be recorded and it will be sent to you in a week or so. If you have any questions or comments, you can leave them in the QA or the chat, and we will pick them up at the end of the session. I expect it to last not longer than half an hour, maybe even a bit shorter. It will be very hands-on, so I didn't prepare much slides. I will be going through the platform and show it with actual examples. So why trend analytics? Well, I like to start with a famous quote from an ancient Greek philosopher, Heraclitus. And his philosophy was that the only constant in life is change. Everything is changing. We are changing. The rivers that flow, you cannot step into the same river twice. And also so in our world, everything is changing. Traffic is flowing. Cars are moving. Planes are landing. And ships are sailing. And trend analytics is really about capturing that change and also finding insights out of what is changing. So the agenda for today, I will be covering different topics. Firstly, I will show you how to look at trends in data by navigating a map, which is in spatial temporal analytics very powerful because in many cases, the location of where things are changing is important. Second thing I will be looking into is when you want to analyze trends in different areas. Think, for instance, you're one of the managers for Starbucks and you want to analyze people flow in New York versus Los Angeles for different Starbucks franchises. Or you're a traffic analyst and you want to analyze maybe traffic flowing through different areas in the city. So looking at different areas together is important when doing spatial temporal trend analytics. But also in time, before after analysis is something that we see very often being used in the platform. The platform enables, for instance, split view analysis. That is very powerful to do a before after analysis. Think, for instance, a road closure. Like, what is the traffic before? And now that a certain road has been closed, how is the traffic flowing now? And the same can be said in the maritime domain. For instance, if you close a certain lock in a port, you might want to analyze how the ships are sailing and how travel times are impacted or wait times are impacted. In many cases, when you analyze trends, you also want to reduce the data to the data that is of interest. For instance, maybe you're only interested in the heavy traffic and not in the regular cars. So you want to filter out some traffic. And it's typically not only about analyzing the amounts, like how many cars are there or how many ships, but also sometimes you want to look into properties in the data. For instance, like what's the average speed over time, or what's the travel time over time? Are people coming from far away? Are they coming from close villages to the center of a city, for instance? And a very powerful feature in the platform is to break up your data into different groups using categories and then analyze trends comparing those different groups. I will also show some ways to customize your trend analytics, for instance, going from line charts to bar charts and so on. And then finally, I will also show you how to build dashboards with trend analytics and maybe some of the pitfalls that you might fall into, and I will guide you to avoid this. It will be mostly an interactive session, so I will be using the platform, and in today's training, I will be using just one data set, and it's with floating vehicle data on a road network. But the data is just GPS coordinates with properties. So if you're in a different vertical, like in maritime or in aviation or in IoT in general, the concepts that I will be showing and the tips and tricks that I will be showing, they apply there as well. If needed, I can go into maybe a maritime example at the end as well. So the example that I will be using, I use it quite often during trainings because it's a very nice illustration of change. And the example here is from an incident that is happening in Germany for already many years, but is still going on. And the incident is basically the closure of this part of a highway. So you see here, you see a density map of where traffic flows. And in those 2 weeks in the data here, we're actually looking at 4 weeks of data so we can do a comparison analysis. There's no traffic or almost no traffic. The traffic that's still there in those 2 weeks is mostly construction traffic. And so basically, if I would highlight the map, just the map, and let me make it a little bit brighter here on the map, you see that even here on the background map, the bridge is not there anymore. So you see like the highway stops here and starts here. So they are rebuilding the bridge. But for now, traffic still flows on the highway here, but it gets off the highway. And then here it can get on the highway again. And you see that depicted also in the road network that is highlighted here. So talking about trends, one way to look at trends in the XYZT platform is here at the bottom of this visual analytics page. And here at the bottom, you see actually a trend over time. You see by default how many trips there are in a certain area. So for instance, if I would zoom in on the highway, immediately you would see that there's still trips in this period of time. So if I move to that period of time, you see them on the highway. But if I move to this period of time, I immediately see there's no trips anymore. So this is like guiding you in your analysis. So this trend analysis. And that is a very powerful feature about the XYZT platform is that it's interactive and it gives you feedback immediately. So for instance, if I would navigate to a different area just by zooming in on that area, I would immediately see on the timeline what the change in trend is like. For instance, before the road closure, and in this case, it's the highway that is closed. It's not this road that is closed. There was about like, you see every 2 hours about like not so many vehicles here, like 75. And in this case, there's like many, many more. So you see the difference in traffic is immediately visible just by navigating around. And the reason why this is important is if you just would have the map and would just have the picture of the map, it becomes very difficult to see change over time. And with the timeline and the trend analysis that you see here, you see immediately the change in what's happening. What you can do then is you can start doing a before-after analysis. And I will be using that with this example quite a bit in the following. But I just want to show it here on the visual analytics page. Here in the top right corner of the map, there's a plus button. If you hit the plus button, you get a second map. You get a second map, you get a second timeline. And also here on the right side, you get a second set of statistics. So you get it basically for the two maps. And by default, those maps will be in sync, so they will move together. And by default, also the timelines will be in sync and they move together. So one way to do before-after analysis is to basically on the left side do the before, on the right side do the after. And you can do that by hitting this button here. You basically unlink the timelines so they can basically behave independently. And this way you can do like a before after. And then like I did before, I can zoom in and out on the map just to see changes in traffic over those areas on the timeline, but I now also see it here in the right corner. I also get some summary statistics. And for instance, I see immediately that there's now about 500% more traffic in this area. So you see how the trend changed quite a bit. And this before-after analysis I will be using also on the trend analytics itself, which is a dedicated analytical page in the platform. So that being said, this before-after analysis we will be doing a lot, but also what people are interested in is to see trends in different areas and compare them. So for instance, what I'm gonna do now, and the reason that I'm doing this is that you see that the traffic gets off the highway in this area and gets back onto the highway in this area. So what I'm gonna do is these areas are of interest to me. Because this is typically where you will have congestion because people have to get off the highway. And also, I would like to monitor how much traffic is still making it to the very last possibility to get off the highway. And this is something that typically, as a traffic engineer, and when you're basically making, for instance, diversion plans, that you don't want people to end up in this area if they don't have to be in the center of the neighboring city. So what I'm gonna do is I'm gonna draw this area. I'm just gonna call this exit 2. The reason I'm calling this exit 2 because I'm gonna add an additional one in the north. So I'm gonna move up to the north here. And you see this is basically the last exit if you come from the north side to be able to exit this area. So I'm going to draw just quickly an area here just before that exit, which is what I want to analyze. So I call this one exit 1. If I now want to compare, for instance, traffic volumes in those areas, I can do the split view and put a filter on the first and a filter on the second, but I'm not going to do that. Instead, I'm going to use the trend analytics, and that's going to be the topic of today. So the way you get to the trend analytics is basically by clicking here on the left side in the navigation bar on trend analytics. And the first time you open it, if you don't have any shapes on the map, like I drew the exit 1 and exit 2 shapes, this is what it will show. It will show you a trend for the global data set. And it's basically taking all the data points in the data set and computing the trend or the temporal variation in the number of, in this case, trips or vehicles. What I'm mostly interested in now is not in this global trend. I'm more interested in local trends. So for instance, what I can do now is, and that's here at the very bottom of the page, I can select areas of interest. And those are the shapes that I drew on the map. Or if you have shape files or GeoJSON files, you can upload them. And you do that here in the left areas of interest part. And those shapes will become available then for your analysis. So what I'm going to do now is I'm going to add those 2 exits. And you see immediately it computes not 1 trend, but it computes 2 trends for me. And that's because I configured it with 2 time periods. And the way to do that is here at the top. You hit, instead of 1 period, you hit 2 periods. And then you can configure the temporal range of each period. And the first period, which you see here on the left in this column, is configured to be the first 2 weeks in the data. That's what you see here. The second period, if I click on the tab here, it's going to go to the second period configuration. It's configured to the last 2 weeks in the data. So you see, I'm sort of comparing those 2 weeks again that I also used in the before-after analysis. And that's what you see here in the middle column. And then in the right column, you see the difference. So this is basically just the difference of those 2 charts. So it shows you during which progression of the period, what is the change? Is it increasing? Is it decreasing? So in this case, we are actually looking, if I go back to the map, we're actually looking at what's happening inside this area and inside the other area. And on the trend analytics, it is plotting for those 2 weeks. It's plotting now number of trips. And you see that in those two areas, there's quite a big decrease of traffic. You see like 50%, 60% decrease of traffic. So it looks like, as an analyst, I see that people are avoiding the area, which is good. There's still quite a bit of traffic. We would hope to even see less traffic, but that's a conclusion that I can make. The trend analytics doesn't have to be limited to just looking at numbers. If in your data there are other properties, for instance, speed is a typical property that a traffic analyst would have. You can also analyze changes in speed. And in this case, we're going to look at the average speed. So you see here that, yeah, and it's swapped to the, because there's not enough space on my small laptop screen. It's swapped to the to show the average over this time period to the second line. But you see that the average speed dropped quite a bit as well. And that's of course because people are queuing and trying to get off the highway. Let's get back to the map and show you, if it loads, show you what is happening in the center of the village. So let me see why it's not loading here. It of course always happens during demo time. Okay, here we go. So getting back to the map, these are interesting areas because we analyzed, okay, there's less traffic. But in fact, in this use case, the real problems are happening here in the center. And you can see that if you zoom from the first period to the second period, you see that there's quite a bit more traffic. So we're going to quantify, well, like how much more traffic. So what I'm going to do now is just quickly now for demonstration purposes, I'm just going to very quickly draw a circle here and call it center. And this is going to be another area that I'm going to analyze over time. So getting back to my trend analytics, I'm going to add my center area. And instead of looking at speed, I'm going to look at number of trips again. So you see the center area is now available here as well. And I can add it and it will compute the statistics also for that center area. And you see it's here. So it now computes like change in traffic, and you see like number of trips has not doubled, but really quadrupled. So there's like almost 4 times more trips going through the center. And then of course it becomes interesting to analyze what are those trips? Where are they coming from? Where are they going to? Do they have to be there? And those types of analytics you can also do with a platform. And here it becomes really, really interesting to do this. And what I'm going to do now is I'm going to look at different groups of data. And in this case, I'm interested in the trips that go through the center of the city, but that don't have to be there. And I think in one of the other training sessions, when we looked at the advanced filtering, this was a use case as well. So the trips that go through the center, but they don't have to be there. Basically, the endpoint is not in the center. And then the other group of trips are the trips that drive through the center, but they have to be there. The endpoint is in the center. And in this case, I'm going to look mostly at trips coming from this northern area. So basically trips coming from exit 1, driving to that center area. If you remember last training session, we also used AI for that. So basically, I'm going to use it again today. So I'm going to ask for show me all trips from exit 1, I think it was, driving through the center, but not ending in the center. What it's going to do now, it's going to basically, for those that did not follow the session on advanced filtering, it's going to use a large language model to basically try to find a filter. And it's a traffic filter in this case, a route filter in the XYZT platform, that complies with what I'm asking for. And as a good human, I'm going to verify the filter to make sure it's the correct one. And I'm going to just open it quickly with you to have a look at what it looks like. So the AI decided to create a route filter, and the route filter says that the trip first has to be inside the exit 1 area, then it can be anywhere, then it can be inside the center area, it can be anywhere again, and then it has a Boolean AND condition, and it says that there should be an endpoint at some point in time, but it should not be inside the center area. And this is exactly what I asked for. So I asked for all the trips coming from exit 1, driving through the center. That's this part here in the middle, but not ending in the center. So what I'm going to do now is I'm going to basically copy paste this, and I'm going to use a small text file just to keep track of it. The other group of traffic, which I'm interested in to compare, is basically the traffic that is actually ending in that area. And I'm going to just modify my filter here in a text editor. I can modify it here and copy it as well. But basically what I then have to remove is this not statement. Basically, instead of looking at the trips that end not in the center area, I'm now interested in trips that are ending in that area. And so you see, I defined 2 groups of traffic, and on the map, we're now looking at the first group, which you see on the trend line here. You see there's quite a bit more in the period after the road closure, which is of course logical because there's no option anymore to stay on the highway. You have to get off the highway if you end up in this area. But still, many people driving through the center, but they don't have to be there. And in fact, you don't want those people to end up on this highway section. You want those people to basically stay here on the Highway 1 area. So that's basically the 2 groups of traffic that I'm going to look at in the trend analytics. And just remember that we have 2 filters now, and those 2 filters we are going to use to define 2 subparts of the data. So back to the trend analytics, and you can do those comparisons here, but in this case, I'm not so much interested anymore in comparing those 2 or 3 areas. I'm really interested in comparing 2 groups or 2 categories of traffic flow. And for that, there's a different mode in the platform, and it's called categorized trend analytics. And I'll open that here. And this is showing you the default view. So nothing is configured yet. So by default, it just shows you the last day, and it shows you the number of trips. So this is just looking at the entire data set, the last day, how many trips are we looking at over time, that is. So also this page has a lot of configuration possibilities. So for instance, instead of looking at number of trips, we could look at the speed. We can take the whole time period. So for instance, I could start after the start of the data and end before the end of the data with a 0 offset. So now it's computing basically that number of trips over time for the whole data set. And in fact, the way that the data was generated was, it is looking at all the trips through that area. And you see that area is being avoided in general. So you see like before there were more trips through that area. So there's a decline in number of people traveling through that total area because of the road closure, which is a good thing. So that's a possibility to do. The platform also allows you here to very quickly focus on a specific area. So for instance, now I'm only focusing on that center area. And we added this selection not only to quickly focus on that area, but also to make sure that you restrict your analysis to a specific area. Sometimes if you do certain filters, that can become important. This page also allows you to do, for instance, to look by hour of day. So for instance, if you want to see the number of trips by hour of day, it's now basically computing over those entire periods the number of trips that are in that area, in the center area that I selected, for every hour of the day, and then it averages that. So that's like the default config. If I'm only interested in the last 2 weeks of data, I can set this to the last 2 weeks, like I did in the second period before, and then I get to see what is here. If I'm interested to have this as a bar chart, of course, I can configure that as a bar chart. One thing that is important to realize in the platform is that I think all the charts that we show by default are adaptive. And that's important to realize. So for instance, you see here at the bottom, this is not 0. This is 1,000. And at the top, it's 4,500. If I look at a different area, for instance, exit 2, you will see that those numbers change. So basically, it is fitting the graph to the min and the max of the data that it computed. And this is important to realize because as soon as you start comparing or you start putting widgets on a dashboard and you put them side by side, it might be that the auto scaling or the auto fitting has a different scale on the two graphs. Now, the way to change that is you click the 3 dots on the graph, you do edit, and then instead of having an automatic vertical axis range, you do a fixed one. For instance, I just take a number here that is sort of fitting my data. So let's maybe take, that's too little, so I take 5,000, let's take 6,000. And this way, if I now switch to a different area and I see my data change, it is relative to the other. It's correctly relative to the other. So also, if I would put charts on a dashboard and they would be next to each other, you will be able to visually compare those charts. So this is important to realize. So let's get to the categories because that's what I wanted to go to. And to make things easy to understand, I will first show you how to make different groups of data based just on a simple data property. And you can do that by adding a property category. So I click on add property category, and it selects the first available property in the data. It selects, of course, a non-numeric property. If you want to use a numeric property, you can do that as well. And in this case, it shows driving profile. So what is driving profile? It is like either consumer vehicles, it is field vehicles, fleet vehicles, it is for hire private trucking fleets. So you see 3 groups of data, basically. By default, it uses all possible values in the data. To give you an idea, for instance, if you're in maritime and you select ship type, there might be 50 properties. And typically you don't want to look at all those 50 properties because then you will get a bar chart with each time 50, every hour 50 bars. So that's quite a bit. So you can still select a subset of the data. So for instance, if I'm only interested in the consumer vehicles and the number 3 or any other property that you want and put on a graph, you can select there. You see here now we're showing it as a bar chart, interleaved. You can also configure it as a stacked bar chart. So this will give you basically the same chart as before. If I would, of course, take all the different possibilities. So the heights are the same as before, but now it's sort of divided in the different groups that you're looking at. So in this case, we see there's much more consumer vehicles over the trend line by hour of day. Of course, if you want to look over the entire time period, you can do that as well. And because I selected 6,000 as my max value, you see that it is still like that. If you don't like the small buckets that the platform selects by default, you can change the bucket size. For instance, now it's on 6 hours. If you just want a bucket a day, you can lower this to 0, and then have this as a bucket per day. So there's many ways to sort of look at the data in time. Sometimes it's by hour of day, sometimes it's by day of week, and so on. So this is one way to categorize your data into different groups. And we will always show you the graph, and we will also show you the table. And the table is sometimes easy to understand what's in the data. It's just a tabular view of the data behind the graph. And this, of course, can be downloaded. So let's get back to our two groups of traffic and the way to get that into this chart. So I'm sort of going to plot. On the one hand, I'm going to plot the traffic coming from exit 1, driving through the center, but that doesn't have to be there. And then the other group is the traffic that drives through the, comes from exit 1, drives through the center, and actually has to be in the center. What I'm going to do then is I'm going to remove this division that I have. And I'm going to go back maybe to my auto, so not grouping by, and let me for now make it automatic so I can just look at the full scale of the data. So the way to do that is you use a custom category, and next to this simple property-based category or an area-based category, you can basically define any custom category, and you can apply any custom filter to that. So in this case, I'm going to call this first one not ending in the center. I'll call not ending in center. And I have to basically edit the filter. By default, there's no filter. And here you see it's exactly the same UI as on the map, the page with the map. Here I can sort of do the same query to the AI. I can ask the same query, or what I can also do is I can go back to my notepad and basically copy paste my filter into this area, and not in the natural language area, but into the filter area. So you see quite an advanced filter, filtering out traffic, and defining my first group of data. I'm going to close this one, and I'm just going to add a second one. It now first asks for the filter, so I'm going to take it from my notepad, which I edited before, copy paste it here, close it, and I'm going to give this the name ending in center. So basically the name here that you see, it's used here on the legend. And you see basically what's sort of the difference. So you see that during the last 2 weeks, traffic that gets off exit 1, driving through the center, but not having to be in the center, is far more numerous than the traffic that has to be there. And this is not a good thing as an analyst. You can then, of course, go into looking at, okay, how does this look like by hour of day or by day of week? You can filter out, if you want, the weekends. You can filter out the nights, only looking at the commute time and so on. So this is what happened after the closure. Maybe to make it possible to compare with situation before, I'm going to take a fixed scale on my timeline. And I can now, for instance, quickly change to the situation before. So in this case, I'm looking at data from the start of the period. So this should be 0 and this should be 14. And you see actually a lot less traffic in both cases. So there's almost no traffic that gets off exit 1, drives through the center, and doesn't have to be there. And that's logical because people would stay on the highway. So when you build a dashboard, you can put these things on the dashboard just like this. You hit the 3 buttons, you do add as widget. I call this demo, I call this before, maybe add some additional context. I go back to my my other configuration, so which is the last 2 weeks, like this. And I add it to the dashboard as well. So I do add as widget, put it in the same group, just quickly call it after. And this is a way to put different charts on dashboards. And you see by default, they're maybe a bit small, so I can edit that. I can make it maybe half the page width and 2 rows tall. And if I do the same on the other one, I make it half the page wide and 2 rows tall. And I have my report. I have my situation before, my situation after. And behind this simple chart, there's actually quite a bit of things going on. Most importantly, this route filter, which selects this subset of data. And with the platform, you can build these types of trend analytics, not just on historical data, but also on real-time data. For instance, you could imagine that you have data flowing into the platform and that this, for instance, is the previous week or the second to last week, and this is the last week, and you always get to see sort of the change over time. So this is a session about trend analytics. I didn't go in all the different possibilities of computing trends and combining trends, but I hope it gave you a little bit of an idea of the capabilities, maybe some pointers to what is possible, and I hope you discovered some new things today. That being said, before we go into the QA, we have one poll to get some roadmap feedback from you. And the poll is related to trend analytics. What functionality should we add next? And the first option is, of course, predictive. Seems like a logical thing when you do trend analysis. Second is alerting. We don't have alerting in the platform yet, but you could imagine that if a certain trend increases or changes a threshold value, that an alert is being raised. Other option is to leverage more on the LLMs, the natural language interaction. For instance, we could use LLMs to ask them to explain trends and changes in trends. And then maybe the last two are for the current users. Maybe you want some more flexibility in combining different trend analytics or in customizing the graphs. So please go ahead, give your answer. And we will take into account in the roadmap. Okay, I'll leave a few more seconds so everyone can answer. Okay. Thanks for that. And with that, let me check the questions first in the chat. There's a question, what are the blue dots if there's no traffic? The answer there is there is probably traffic then. So there sometimes when there's a road closure, the fleet vehicles, the trucks that are being tracked might appear in the traffic. And we've seen that in many cases when there's road closures, there's still traffic on the road because of the construction going on. Yes, there's a question about feedback on the product. Yes, of course, please send any feedback. The email address is at the end. And then there's a question, could you show again how you funneled the two graphs into widgets? Let me check what is meant with that. So I think the question is about how I got to basically those two widgets. So basically what I did is if I go to the trend analytics, and let me maybe to really start from scratch, reload the page. So what I did in the end was I went to the Categorize trend analytics. I selected the time period, so the first 2 weeks versus the last 2 weeks. And I just use as a time axis a continuous scale, so no bucketing in hour of day or day of week. And then I added 2 categories, basically 2 groups in the data. And the way I came to those groups is by, on the map, first drawing a couple shapes using the drawing controllers here. So I drew them here, and then I derived a filter that analyzes traffic flow through those shapes. And the first filter, let me show that here in the UI. The first filter was one that I had asked the AI for, but I just gonna copy paste it here. And this filter, what it basically does, it looks at traffic at some point driving through this area, then at some point driving through this area, and then finally the endpoint not inside that area. And then if I remove the not here, it will also give me the traffic that, or instead of also, it will give me the traffic that drives through the center at some point and also has the endpoint in the center. So this could be traffic that has to be in the center, maybe to deliver a package. And then I see that was understood. So, and then here I use that in the categories. And that is done here. So you have different options to sort of have 1 or 2, 3, 4 graphs. So I added a custom category. And in the custom category, I added the first group, which I called, I think, not ending. And I can add a second group. Let me close this one first, ending. And then I put those 2 filters that I made behind those groups. And the way to do that is you just hit filter and you get the same filter panel like on the map. I can just copy paste the 2 filters that I had. So for instance, this one, I copy paste here. It's the one not ending. I can close that one, close it up. And then I add the other one here. And we're almost getting to the widget part. So bear with me. I'm going back to my notepad here. I'm copy pasting this, putting it here, and closing this one. And so now I have my chart. I only have it for the last day. If I first want to look at the first 2 weeks, typically I do that first because then that widget is on the left side and the last 2 weeks will be on the right side. So I choose here the first 2 weeks. So I do that like this. And it's now computing that. And then once that is done, let us wait for a second. You see it's still computing this one. And then I added basically that widget. So add as widget here. So that's basically, yeah, what I did with the 2 filters there. And on the dashboard, I, in the end, end up with those 2 widgets. I hope that helps and that clarifies that part of the training. Don't worry, the training is recorded as well, so you can always replay that. Okay, I see a positive outcome, so that's good. Final question maybe that I see in the chat is, can we export the charts? Can we export the data is the question. The answer is yes. Different ways to do that. For instance, if you hit a button here, you get back to the chart, and in any place in the platform, you can right-click on a chart and you can do save as, or you hit the buttons here and you can save as. So that is everywhere possible in the platform, and you can open it in Excel. So that's how you export it. And typically when you see the table also, that's actually what the export will look like. There's one more question that just came in, and I think we still have a minute or so to answer that. So how do you explain the trends depicted in the graphs? I assume the question is related to this. So in this case, not ending in the center. Well, the area that we were looking at when I created these, and I'll zoom in on it again because I didn't do it in the second time, I realize. The area that we're looking at is the center area on the map. So if you look at the center area, it's this area. So on the one hand, there's a filter that filters the traffic coming from here, driving through the center, getting into the center again or not. But then on the second part, when we just look at the center, it is sort of counting the number of cars, the number of trips in that area. And before the road closure, and we can see that here as well very easily, before the road closure, most people that needed to pass through this area, most people would drive here and stay on this highway. But now all those people have to drive that get here because the road is closed, and that don't have to be in the center area, but they sort of want to drive north to south on the A45. They have to find their way through the center. And I should not apply this filter, but basically you can see it here. If I just apply people coming from exit 1, you see how they drive. There's a lot of traffic now driving through the center area. And if I would zoom in on the center area, you would see that as well here in the charts. You would see this almost the same graphs here. You would see very little traffic before the road closure, but a lot of traffic during the road closure. And that's what we're looking at on the dashboard now. So you see that the people that are driving through the center, and they actually don't really have to be there because their endpoint is not in that area, has increased dramatically, like multiple hundreds of % increase. And that's what this graph tells. And if you would look up this situation on the internet, people in that city called Ludenscheid, they were complaining a lot. And the reason that the road authorities are using our platform in that area to do this type of analysis is just basically because of this situation. Like there's too much traffic driving all the way to the last possible occasion to get off the highway. And so basically what the road authorities really want is that people coming from the north, they take this route. So they take the 1 instead of the 45. So they're doing that analysis as well. One more question, I'll just try to answer the questions we get. So what type of file was imported in the beginning that gives all this traffic data, I suppose, which is just traffic volumes in the city? Yeah, very good question. Very good question. And I skipped that part. I didn't even show it in the beginning. So this is data from a company called Inrix, and it's trips data. And trips data is basically data consisting either of GPS points or sequences of road segments followed. So it's not traffic volumes. It's really actual routes that people take. And that's why we can do the route filtering. If it would have been just volumes, you would not be able to look at only the subset of the traffic that I was showing, the traffic ending in the city or not ending in the city. And that's really powerful about the trips data. So I think that answers the question. I see a thank you. So with that, I would like to basically conclude this training session. I would like to thank you for following all. The recording will be sent out in a week or so. And for any feedback, suggestions, also on the platform, I saw someone wanting to give some feedback. So that's very much appreciated. Just reach out to me. That's bart@xyzt.ai, or the general email is info@xyzt.ai. I apologize for taking 20 minutes more, but there was some interaction, so that's always nice. So thank you for that. And with that, have a good day. I want to advertise the next training, which is June 11th. And there we will go into all the different types of data that the platform supports, including also a new data type that we added about a couple months ago, which is called movement path data. So with that, I would like to thank you and see you next time.